All right, so for today's lesson, it is 422 and it's about correlation. And we've talked about the word correlation before. And basically it means like, is there some sort of connection? Are the two variables correlated? Do they have a connection or a relationship? And today we're going to talk about correlation coefficient, meaning a number associated with how tightly related those two variables are. So we have to still use the least square regression line because what we're doing is we're checking to see how close the points are to that least square regression line. If you wanted to compare data, you can only compare that sum of the squares of the residuals if the two people are using the same data, the same graph, and maybe they've just graphed different fitted lines. But a correlation coefficient is a general term where you can compare anything. Even if I'm talking about data from a softball game and someone else is talking about data from a field hockey game, we could still compare those correlation coefficient values, which are represented by a lowercase r. It's talking about how strongly the points are related to the fitted line. So normally what we would do is we would do this in teams, but I'm going to sort of walk you through what that would look like. What we have here is a graph, and it said in the directions just to select any 3 points in the first quadrant. So I did that. I selected 3 points. The points were 2, 4, 4, 7, and 8, 6. And it asked us to use the calculator to make a scatter plot and determine the least square regression line. Now, you guys have these notes all filled in. If you want to follow along on the calculator just for practice, that's a great thing to do. So what I did was I pressed Stat and Edit, and I entered those 3 points. The first coordinate was 2, 4, the second coordinate was 4, 7, and the last coordinate was 8, 6. Once I had them in, I went up to the y equals, and nope, not y equals, sorry, second y equals, and I turned the scatter plot on, right? I hit enter, turned my scatter plot on, and then I pressed graph. You are going to get all of the axes, all the coordinates, all the quadrants. Got there, third try. And that's okay. You can, if you want, you can do zoom stat and you can zoom in on just the 3 points if you want. At this point, you don't have a fitted line. You still need to do second stat or just stat and go to calc and go down to option 8. We did talk about how option 4 works as well. If you go to option 8 for a line of linear regression, we would go down to storing our data, and we want to go vars and over to yvars, and we are storing a function, which is enter, and we are storing it in y1, and then we would go down to ask it to calculate, and that's how we get our least square regression line. Y equals 4.5, which is the intercept, plus 0.25x. We can also, since it's been stored, we can hit y equals, and we can see the equation there as well. And if we press graph, we can see that that fitted line has been substituted for us. You can notice that I took the y-intercept of 4.5, and I took the slope of 0.25. Now, in my head, I thought of that as a slope of 1/4. So for every time I went up 1, I went right 4, up 1, right 4, and that's how I drew in my fitted line. Now, the thing you haven't looked at before, we've just sort of pretty much ignored it before, was stat, calc. If I'm going to go down, just to bring this up onto my screen again, you might not have to do this again if you didn't leave the screen. When you calculate your least square regression line, down here at the bottom, there's an R value. R equals 0.5, or in this case, they just write 0.5, but R equals 0.5. That's the correlation coefficient. That's the number that says whether or not the points are very closely lined up near the fitted line, or they're only kind of close, or not close at all. We haven't talked about what that number means, but you would write it down and be like, okay, great, this one has an R of 0.5. You can see on the page there were 2 other examples as well. I picked 3 points that had a negative correlation, so they had a slope of negative 1.4. You'll notice that R is also negative. So on here, the slope was 0.25, and I had a positive correlation coefficient. The slope was negative 1.4, so I had a negative correlation coefficient. And then over here on the right, I picked 3 more points, and I had a negative slope, also had a negative correlation coefficient. So for right now, the first thing we know is that positive slopes have positive R values and negative slopes have negative R values. Just the place to start there. All right. Now, if I look at the top of the page, it says, for parts A through E, use your calculator to make a scatter plot and determine the least square regression line, make a sketch of each graph below, and record the value of the correlation coefficient. Start by graphing any 2 points that have integer coordinates and a positive slope. Each member of your team should choose different pairs of points. So we did that. We just did 2 points. So you'll notice that this line only has 2 points to start. And I've got y equals 3 plus x, has a slope of 1, a y-intercept of 3. And the next thing that we did was we added a point to each one of them that stayed on the line. So I have 3 points that line up perfectly. Can you see 1, 2, 3 points that are all in line? On this one, 1, 2, 3 points that are all in line, and then 1, 2, 3 points that are all in line. If all of your points fall on the fitted line and they are a perfect linear correlation, you will notice that the R value is a perfect 1. 1 is the best value you can hope for in a correlation coefficient. That means that you have a perfectly linear relationship. Now, the ones that are below that, first, we picked 2 coordinates that had a negative slope between them. And then we picked a third point that also fell on the line. So if all 3 points line up perfectly, they are a perfect linear relationship, you will notice that the R value is a perfect -1. So -1 is also perfect. It just is a negative slope perfect. So if your R is +1, that means it is a perfect linear relationship that is a positive slope. And if it is an R value of -1, that is a perfect linear relationship with a negative slope. And that's all we got out of that second page. Now, you're welcome to type in pairs of coordinates and go through the process so that you can check it. But that is the outcome of the second page. That's what we want to take away. Third page. It says, start again with your 2 original points, enter a third point that makes the slope go negative. So in the 2 original points here, I had a y equals 3 plus x, and I had an R value of 1. So I want to walk you through this one. So same thing I always do. I'm going to go second memory. I'm going to go down and reset my memory. I'm going to reset all of the RAM. And once I've done that, I'm going to go second catalog, and I'm going to turn my diagnostics on. And I'm going to substitute into the table. I want to make sure it says done, right? I don't just want to get diagnostics on. I want to make sure it's done. I'm going to press stat and edit. I've got a nice clean table. One of my coordinates here was 2, 5, 2, enter. And then I go over to the other column, 5, enter. So you'll see I get coordinate 2, 5. And then I also had 4, 7. So I'm going to go back to the X column, 4, enter. And then I'm going to go over to the Y column, 7, enter. And if I graph them, nope, I got to turn the stat plot on because I turned it off last time. So turn stat plot on and then graph them. And you get the 2 points. So those are my 2 original points. And you can see that from the page before, they had a perfect R value of 1 because any 2 points is a perfect line. And then they had a slope of 1 and a y-intercept of 3 for 3 plus x. Then I went and threw this one into the mix, 7, 0. So now I have 3 points. I have 1, 2, and now I'm going to type in 7, 0. So I'm going to go back to stat, edit, and I'm going to add in a coordinate 7, enter, and then I'm going to go over 0, enter. So now I have a third coordinate. I want to find the least square regression line for these new 3 points. So the original 2 points formed a straight line because any 2 points will form a straight line. Any 2 points will have a perfect R1 value or an R negative value if they happen to be negative, a negative slope. So I'm going to do stat, calc. I'm going to go down to linear regression, and I'm going to ask it to store vars. I'm going to store it under y vars, and it's a function, so I'm going to hit enter, and y1, so I'm going to hit enter, and then I'm going to ask it to calculate. And now all of a sudden, I have an intercept of 8.789, which you can see is like up here. And I have a y value, my slope value is -1.1. So now I've gone from a positive slope to a negative slope because this 7, 0 coordinate just pulled my line toward it. It's trying to keep all 3 of the points as close to the fitted line as possible. And now you'll notice that my R value went to a negative 0.77. So it's not a perfect -1, which would be 3 points that lined up with a slope that's negative, but it's not terrible. I'm saying, okay, it's not 0. 0 would be just points flung everywhere. So it's not a perfect -1, but you'll see the points aren't terribly far away from this new purple line, which is my new fitted line. And if I graph it, you can see that it plotted 7, 0, and it plots my new fitted line that is now negative. And you can do the same thing with the other 2 examples that are there. The last thing we want to do, it says, start with your original 2 points from part A. Choose a third point that makes R close to 0. Something that is as close to 0 as possible. So we want to try to get a fitted line that is like nearly impossible to get it near all of the points. So my first 2 points, I'm going to go second quit, and I'm going to hit stat. I'm going to edit my table, and I'm going to take out that 7, 0 coordinate using the delete button. And I picked 5, 4. Do you notice how I kind of put my 3 points like a triangle? Because there's not going to be any really good way to fit a line in a triangle. So 5, 4, 5, enter, and then go over to 4, enter, and get 5, 4 as a new coordinate. And I'm going to go second stat. Nope, just stat. Sorry, guys. Calc, and I'm going to go down to 8. And I'm going to store it in vars, y vars, because I want to store it as a function that starts with y equals. So I'm going to use y1. And I'm going to calculate. And look at how low, how close to 0 my R value is. Something between -2 and +2. Yep. So what we're saying is those 3 points do not tend to go in a positive direction. They do not tend to go in a negative direction. They would be your no correlation. There doesn't seem to be a reasonable connection where I can make a good fitted line there. And you can try the same thing here, where you'll notice that I had 2 points that made a nice straight line because they're 2 points. And then I tried to throw in a third point that kind of made a triangle. And that way it was really hard to get a good fitted line. And I ended up with an R value of 0.16. And over here, I threw in another one. If I had put it even a little further away, like instead of 8, 4, if I maybe went 10, 4 or 12, 4 and made it more of a big open equilateral triangle, I could have even gotten lower than the 0.19. All right, the last thing that we want to look at is there's like a multiple choice here on the last page. It says the following scatter plots have correlations of R negative 0.9, R negative 0.6, R of 0.1, and R of 0.6. Which ones do we think go with which picture? So this one, first thing I'm going to notice is it's a negative slope. Second thing I'm going to notice is those points are really, really tight along that fitted line. So I want something that is negative and probably really close to -1. So out of my 4 choices, I would say this one is probably a negative 0.9, really close to -1. Negative slope, and the points are really close to the fitted line. This one, the fitted line has a positive slope, but do you notice that the points are scattered everywhere? And literally all 4 corners of the graph, a little bit of everywhere. So I need something with a positive slope, but a really bad correlation coefficient, something really close to 0. So this one I would say is probably the 0.1. It's positive, but it's not good. This one is also positive. You can see that this corner's kind of empty and this corner's kind of empty. They are following in a positive direction, but they're really spread out. So it's going to be positive, but not great. So this one I would go with the R equals 0.6. And then this one is a negative slope. And I would say the same thing. They're not very close to the fitted line. I've got a couple corners that are empty. So it's a negative slope, but not really great. R in this case would be negative 0.6. The last one I'm going to do is skip down here to the bottom, 4-72. It says in problem 4-1, you completed an investigation that helped Robbie use a viewing tube to see a football game. Sample data is shown in the table below. We came up with a least square regression line of 1.66, which is approximately the diameter of the tube, plus 0.13x. And that's how much wider of a view we get for every inch from the wall. Determine the correlation coefficient. Is the association strong or weak? So we would need to go back, and you may want to pause the video at this point. You may even want to fast forward through it, depending on how much you want to do with me. I'm going to reset all of my data again. And I'm also going to do my diagnostics on. Remember, in order to get that R to come up, we have to have diagnostics on. If you forget and you get to the screen where it should be and you go, oh, shucks, I forgot, you can always go back, turn diagnostics on, make sure it says done, and then run the least square regression line again, and it will pop up the second time. I'm going to press stat and edit. I'm going to enter in the values from the table. And this is the part you may want to fast forward through, or at least mute me. I don't do the quiet thing very well. I am going to check. I've got 8 points. I have 8, 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. So that's good. 20.7. I almost made a mistake there, and it would have shown up as being a really big problem in the checksum, and that's the point of the checksum. And 14.8, 13.1, 11.4, and 9.3. And I've got 8 pieces of data. You'll notice that they match up with each other, so that's good. I do have the checksum that I can do if you want. Second catalog. And remember, we wanted to go up because we were finding the sum of the set of data, and up brought us through the bottom of the alphabet first. So sum, obviously starting with letter S, closer to the end of the alphabet. And we want to go sum, and then the blue second key, and press 1, and that'll plug in list 1. The sum of list 1 is 816, so that's good. The shortcut that I had told you before, if you press second enter, it will bring up whatever you did last. And if you go in here to where it said L1 and you delete L1, then you can do second 2 without having to go through the list again and have it do the checksum for list 2, which is 122.4. That's awesome. We can do second stat plot, and we can turn it on, right? Second, and then the Y equals key. We'll go into our statistics plots. We want to turn the scatter plot on and press graph. We notice that nothing's there. We need to do zoom, and we want to do zoom stat so that our stats show up. That's good. That looks a lot like our graph did way back on the first lesson. All right. So now that we've got it graphed, we can do stat, and we can ask it to calculate our least square regression line for us, and we want to put it in y-vars. It's a function. It's going to be under y1, and calculate. Press pause right now if you're not at the same screen and you need to catch up, or you need to go back and figure out how to get to here. If you turned your diagnostics on, you got an R value of 0.997, which is awesome. It is almost 1, meaning that it's almost perfect. We can also say that it is linear, and it's strong, it's positive, and from the graph, it didn't appear there were any outliers. So we would say first that it is strong. R is approximately 0.997. I did have to round. Describe the form, direction, strength, and outliers. We would say it is linear. I mean, for all intents and purposes, guys, like, take a look. It's linear. It does not look curved, but we can check. Linear, strong, positive, and no apparent outliers. That last thing that we'd want to do, just to be sure if it was in fact linear, was the residuals and the residual plot. We can do that on the calculator. If we go into stat and we edit and we fill in that list 3, don't forget you got to be way at the top where L3 is highlighted. And we want to do second stat. And this is the one where we come down and we ask it to find the residuals. And it says, yep, in list 3, I'm going to put all your residuals, and you hit enter. And it does that for you. In order to look at the residual plot, the graph that plots this data, you want to go back into stat plot, and we want to go to plot 1, but we want to change that to list 3 so that it will graph our residuals instead of the Y variables. And that's not much help, is it? I don't really need that fitted line. So I can do Y equals, and I can turn that fitted line off. If I go over to the equal sign, I can hit enter, which turns that line off. Graph. Okay, well, I turned the line off, but I still don't have any points. I'm going to do zoom stat, because remember, your data is going to be all around that x-axis. And this is great. This is exactly what we want to see for linear data. We want to see some points above, some points below, scattered from left to right. They're not all clumped together. So this does appear to be linear. And based on our R value of 0.997, it is a positive slope and it's super close to 1, so it's strong. And the residual plot seems to support that it is, in fact, linear. I don't see any outliers. Looks pretty good. So I think we did the right thing picking a linear model for this sample data about the person viewing the football game through the tube. If you guys have any questions about how to get the R value or what the R value means, we can talk about them in class. Bye.